In a recent series of videos that I've posted, I went through the repair of this Rigol DP832 linear power supply. Had a fault with it where it was randomly resetting itself and it was getting rapidly worse. Went through what I found. It's now been running for several days without resetting, so I'm fairly confident now that this problem is fixed. And in response to the previous video in which I said I was going to put this on long-term test, I was asked if I would be applying various loads to it as part of the test procedure. So I just thought I'd quickly show how I go about testing this before we move on to the real topic of this video. And so what I normally do is program the Rigol supply to cycle through various modes. So in this test it's cycling between 0 volts and 30 volts. It will do that 1,000 times, and then it will switch to a different voltage range and do the same thing, a different current range and do the same thing. I've got it hooked up to a Kunkin KP184 that's set up for constant resistance, and this is set at the moment for 30 ohms, and again I vary that over time. But I'll just leave it running. Now, because if the Rigol resets, I'm not going to sit here and watch this for weeks on end. I want to know how long it ran for before the reset. I have an Agilent 34461A bench multimeter hooked up, and this is set up to log the voltage output from the Rigol. And it looks like a mess at the moment because it's showing all the values, but you can see it's recording the data, and if the Rigol does reset, then I can export the data into an Excel spreadsheet and see exactly what went on prior to the reset. So this will be left now for several weeks to make sure that it's behaving itself, but this is how I normally go about testing something like this, and these step changes are obviously giving the Rigol a fairly good workout. This video is about what I intend to replace the Rigol with. As I said, I've lost confidence in the Rigol, or more specifically in the support that I didn't receive when I reported this fault. Rigol seem to have been aware of this for some time, but have done nothing to fix the problem for previous owners, and haven't even made this information available in the form of a technical bulletin, which I didn't think was very good. So as I say, I've lost confidence in Rigol, and I'll just get this test setup out of the way, and we can have a look at what I'm replacing this power supply with. In case you think I'm being unfair on Rigol here, then I will just point out that I have been a supporter and a fan of Rigol products for quite some time now, and over the last 10 years I've spent over £40,000 on Rigol products, all sorts of different products. I've got a spectrum analyzer here, I have other supplies from them, oscilloscopes, I've got a whole range of equipment from Rigol, and for the most part it's been okay. One of the things I like about Rigol is the apparent build quality. They use very nice materials, nice plastics. I think they go out of their way to make their equipment actually quite heavy. I think when you take these apart you'll see what I mean. They do seem to be heavier than they really need to be, thicker gauge steel, that sort of thing, and it gives them a nice feel. I quite like it. They use extremely nice quality plastics, and as I say, for the most part they work fairly well, but I've kind of lost confidence in them a little bit with this power supply. I've got some other equipment from them I've had some problems with, but for the most part it's been fairly good. So I'm not picking on Rigol here for no reason. Like I said, I've spent tens of thousands of pounds on their equipment over the years, and really was very disappointed with the power supply, and specifically with their response to it. Okay, so I'm going to get on the bench now what I intend to replace the Rigol with. Might be a bit of a surprise to some people, but as I say, I want something that's reliable. I can't have a supply that turns off halfway through a 20-hour experiment. Okay, so as a direct comparison, here we have the Rigol DP832. This is the one I've just repaired, and what I'm replacing this with is an 01 ODP 6033, and so you might find it surprising that I've gone from what is meant to be a kind of medium range supply to what has traditionally been a very low cost, cheap manufacturer. And in fact, I bought an 01 oscilloscope about 15 years ago now, and it did the job. It was a very low end scope. I think I paid something like £160 for it, and 20 megahertz or something like that. Horrible plastics they used. It was extremely light, you could twist and bend it, but it worked. Terrible display it had, and it felt cheap and nasty, and I think this is one of the areas where 01 have really improved in the last few years. They've started using much better materials, and just in general the quality of their products has gone up. And if you've watched my videos, then you'll know that I'm always very keen to give even low-end manufacturers an opportunity to sell something to me, and I'll give it a good shake and see if it actually works. But having said that, this is obviously a lot cheaper than the Rigel, and so the direct comparison isn't really that fair. So just to make it a bit fairer, I've actually bought two of the 01 supplies. So what I paid for these is the same as what I paid for the Rigel, and I actually got two different models of the 01 supply. So I've got the ODP 6033, similar kind of thing to the Rigel DP832, except that it's 0 to 60 volts 3 amp 3 channel instead of 0 to 30 volt 3 amp 3 channel. So it's twice the output voltage of the Rigel. It is bigger. It's probably about 30 millimeters wider, 20 millimeters taller, although it has got the feet on still, which I'll take off. I took the feet off the Rigel just so it fits into the bench more easily. Same depth, if anything, the 01 is slightly shallower. It's about 20 millimeters shorter, and of course the two are identical in size, same cases. The second one is the ODP 6062. So this is 0 to 60 volt 6 amp, but it's only 2 channel, but it does have a sense input. So what I'm going to do is, I don't normally do this, but I'm going to tear down the 6033. We'll have a quick look inside. It's going to invalidate my warranty, but warranties tend not to mean that much these days anyway. And we'll have a look inside just at the general quality of build. It'd just be interesting to see how 01 have progressed, and how these look inside. Just get rid of the cover. Okay, so I'll get this case opened up, we'll have a look inside. I'm not going to do an in-depth teardown, this is just a quick look inside this, and then we'll power it up and see how it behaves, and how the general features it has compared to the Rigel. One thing I like straight away, it's got a proper keypad. Okay, so what I'll do now is tear down the ODP 6033. It's not going to be a full in-depth teardown, we're just going to have a quick look inside, try and get some idea as to the quality, see if it compares at all with the Rigel, and then I'll get it reassembled and do a comparison with the Rigel, and see if it was worth the money I paid for it. And I'll do something similar with the 6062. These will be fairly brief, I'm not doing a full in-depth review, and if you do want to see more information and more of an in-depth test, then let me know. But this video is just really to kind of introduce this and explain why I'm moving to these and away from the Rigel. Okay, well here's an inside view, and I have to say so far I am actually rather impressed with this. The quality of build of this is way better than the scope I mentioned. I don't think it's better than the Rigel. In terms of design and layout, I would say it is better than the Rigel. It's got a very nice design for the thermal cooling. Massive channeled heatsink with a fan directly built onto it, so it's going to be very efficient in terms of cooling. Now of course this does have twice the output power of the Rigel, so it did need something a bit more substantial, but the way that this is all arranged is extremely nice. It's also nicely finished. There's some fairly substantial metal parts in here, but unlike on the previous 01 products, these are not just left raw. These have actually been finished off and rounded over, so there's no sharp edges on this, no rust anywhere. The metal case fits extremely well. It's all goes together nicely. The PCB could have done with a bit more flux washing, but the same was true of the Rigel. Looking at that, I'm not going to tear this out completely. As I said, this is not a complete tear down. This is just a quick look inside. Very nice metal chassis. All the boards look good. All the cables are held in place with some compound, and some very nice big beefy transformers in here. Two huge transformers. All the wiring is relatively neat and tidy. They could have made it slightly tidier, but nothing wrong with this whatsoever that I can see. I've had a good look round, and there's no sign of any trapped wires, anything like that. The circuitry all looks to be nicely assembled and put together. Similar kind of concept to the Rigel. We've got the analog control board and then a digital control at the front, and in front of that is the display and keyboard. Yeah, so far I'm actually surprised by the quality of this. I'm very surprised with the quality of the power setup. There's a whole row of high power MOSFETs down one side of the heatsink, and then this is mirrored on the other side, presumably for the second main channel. At the front we've got all the filter components, and they all look quite nicely assembled. As I say, it could have done with more of a wash. You can see there's some residue coming off this, but it's not too bad. The board quality looks good. They've even rounded over the corners of this, so some attention to detail, which is unusual for low-end products. But as I say, 01 do seem to be stepping up their game recently. I wouldn't say they were on a par with Rigel in terms of apparent quality, but let's see how this behaves when we try and power it up. But certainly looking inside, I'm impressed. It's a nice and neat layout. The previous 01 things I've torn down have been kind of a mishmash of parts and cables running everywhere, but this has been well thought out, and certainly they have used some nicely rated components. And looking at the way this is arranged, it looks like these two channels are truly independent, even down to the transformer level, so that's extremely nice attention to detail. Okay, so I'll get this reassembled. If you want to see more of this internally, let me know and I will do a full teardown. For this video I just want to do an operational comparison with the Rigel. I haven't tried powering this on yet, so let's hope I haven't broken it. I've reassembled the unit. I've left the handle off for now, just so I can stand the multimeter on top. And not much to see on the back. We've got another cooling fan. Again, it's lined up with the internal cooling structure, so that's again quite a nice thermal design. It's got a fan at both ends of that, so it should be fairly efficient. Probably quite noisy, but we'll see how it goes. We've got LAN USB device serial port. You can see this particular unit has been correctly set for this country, so we can get this out of the way, and we'll spin it round, get it plugged in, and we'll try and power it up and see what happens. So I haven't tried switching this on yet, and has got a mechanical on-off switch. I'll make sure that's switched off. Get it plugged in. I'll just tilt it up a bit so you can see it a bit more clearly, and I'll just adjust the camera so you can see the screen square on. Okay, so we'll try and power it up, see if I've managed to break it already. So I'll let it boot in real time so you get some idea as to how long it takes. Okay, it's up and running. So about the same time as the Rigel, and actually a surprisingly nice screen. One of the main issues I had with the previous O1 products I've had is they use an extremely poor LCD. I was going to move the lab lights a bit, they are a bit bright, so we had to see the supply a bit better. Okay, so as I say, nice display, nice and bright, good colour, nice and clear. Okay, so we'll see if the various buttons work, so we can change modes. I don't know how to operate this yet, I haven't looked at the manual, but we can change the various modes and put it into parallel or serial or whatever to have a very flexible power supply. This particular model's got 3 channels. It's very similar to the Rigel. We've got, in a strange order they've got them in, but you'll understand why this is when we look at the 6062. So we've got channel 1, it's 0 to 60 volts at 3 amps, channel 2, which is the same, 0 to 60 volts at 3 amps, and then we've got channel 3, which I think is 0 to 6 volts at 3 amps. And obviously that's twice the output of the Rigel. Bit of hum coming from it, more than from the Rigel. The quality of the case, it's not quite as good as the Rigel, but it's certainly a lot better than all the other O1 products I've had before. So that feels quite nice. Doesn't have any speed response, it's just directly related to the number of clicks, but that feels okay. It is clickable. Quite nice. As I said, I don't know how to operate this yet. It seems to be extremely self-explanatory. That all works fine. Okay, I'll get set up. I'll get electronic load attached to this. We'll get the multimeter on top, and I'll get a scope set up so we can have a look at the output from this. Okay, so I've got this set up. I've got the Agilent 34461A monitoring the output. We're looking at channel 1 here. I've got the Kunkin KP184 connected. Again, it's in constant resistance, set to 30 ohms. I've got the scope connected across the output of channel 1. So we'll do a few quick tests. This is not meant as a full review. I just want to see in general if this power supply looks like it's going to be any use for what I want. What I'm looking for is a good bench power supply, one that's stable, one that will stay switched on when I tell it to, and one that has reasonable output. Now, one of the things with this OP6033 is that out of the box it has 3 decimal point for both voltage and current, and that's a cost option for the Rigel. This comes with that as standard. This has got up to 60 volts output for channels 1 and channel 2 compared to 30 volts for the Rigel. Current output's the same, so basically twice the output, but we'll see how well that responds. The first thing I want to do is see, roughly speaking, how accurate this supply is. As I say, this is not going to be a full review, so if you do want me to do an in-depth review on this, then let me know. But all I'm doing here, as I said, is to do a very quick appraisal and see if this looks like it's going to be any use. Okay, so I don't really know how to use this yet. It looks fairly clear. There are some nice features in here according to the manual, so you can record, so it'll log data and set it up to have outputs that change in the same way that you can program the Rigel. So first thing is we have 1 volt set to 2 amps, I think that's just the default. We have the limit set at 61 volts, 3.1 amps, you can of course change that. And if we turn this on, we should see a voltage on the Agilent. That's looking quite good, so we're within a millivolt of the correct output, which is actually quite impressive. Okay, we'll try a higher voltage, and I'll change this up to 2 volts. Okay, that works quite nicely. And again, we're actually only a few microvolts out. That's very impressive. We'll turn the electronic load on and see how much this changes by. Okay, that's very impressive. That's about a quarter of the change we had with the Rigel. Turn it back off and see if it goes back. Okay, that's actually quite impressive. We'll go to 5 volts and see what we get. Very close. We'll turn the load off. Back on. Okay, that's actually looking quite impressive. What I'm going to do now is some basic response tests. So we'll firstly start with a power on test. So I've got the scope set up. We'll set it to trigger on the rising edge. And we'll do a single shot capture and we'll turn the power on. Very nice clean rise, that's actually quite impressive. That's with the electronic load turned on. We'll do the same thing now with the load turned off. And the supply back on. It looks pretty much identical. So what we'll do now is a differential. We'll change the voltage on the supply and see how it responds, and whether it makes a nice clean transition up to the new voltage. So we'll arm the scope. We'll go take the supply up to 12 volts. Again, very nice clean transition, and we'll do the reverse. We'll go down from 12 volts back to 5. That's the button. Okay, a lot slower going down. The load is off, so we'll try the same thing with the load turned on. So back up to 12 volts. Electronic load is on. And we'll go back down to 5 volts and see if it responds more quickly. And indeed it does. Okay, so this is looking extremely good. There's no overshoot. It's only taken a few milliseconds to get to the voltage that we're setting, and what we can do now is try the entire range of voltages and see how the supply looks. Before I do that, I want to quick look at the noise level on the output and see how it changes when we vary the load on it. So I'm going to change the coupling on the channel to AC, and we've got bandwidth set to full, and we can now increase the scale, get it to run. So that's 50 millivolts per division. The power supply is turned on, by the way, so okay, I'll turn the electronic load off. Back on. We'll increase the scope. So that's 10 millivolts per division on the scope. Oops, actually, that's a bit suspicious there. It was a bit too quiet, but it is working. It's actually connected. Cycle the electronic load. So a small spike there as the load is turned on and off, but it's only 25 millivolts, so that is actually very impressive. I'm so far extremely surprised by this. I was expecting less accuracy, but also a lot more noise on the output of this supply. What I'm going to do now is try and do the same thing but load up the supply. So we'll reduce the resistance that the load is set to. Okay, so that's 10 ohms. Trying half an amp. So up to a bit over an amp. We'll go up to 10 millivolts. You can see the voltage is still very close. We'll turn the load off. So we're now going to go to zero load. Okay, that's looking extremely promising. It's actually surprising me. I wasn't expecting it to be quite as accurate as this. So down to 1 ohm load. We can see we're cycling now. This is because of the mode that the electronic load is in. This is the electronic load that's causing this, not the supply. Okay, so we'll try increasing the current. So that's the limit for this, 3 amps. I don't know if it actually let us go up. So we can go to 3.1 amps, which is the limit. I don't know if we can go beyond that. I'll try that another time. And what we can do now is start to increase the voltage. So go up to 3.1 amps as the limit. We'll drop the resistance back down. You can see it's not cycling now, but this cycling is caused by the interaction between the electronic load and the supply. It's not an inherent issue with the supply or with the load, come to that. Okay, try increasing the voltage. So again, you can see the electronic load cycling. So it's one of the downsides of using electronic loads like this. They are a bit of a pain. You can get around this by changing this setup of the load, but what I'm trying to do here is get a decent amount of output power from the power supply. So I'm going to set this to 10 ohms and turn the supply right up to 60 volts. You can see there is protection built into the power supply as well, so it shuts down the output if it needs to. So again, another nice feature. So we'll turn that back on. So 1 amp, that's good. Start trying to increase the voltage. We've got to 20 volts. So it's now putting out about 40 watts. And we're just 7 millivolts under the limit. We'll try turning the load off. And it maintains voltage very well. We'll go up to 30 volts. So it's now 88 watts we're putting out of the supply. Still just a few millivolts away from being correct. We'll go up to 40 volts. And again, because we exceeded the current output, it's shut it down, which is exactly what it's supposed to do. So it's actually looking quite good. You can go into constant current, by the way, and it won't then do that. It'll keep running. But what I'm trying to do here is see how much power we can get out of this and what response we get from the actual power supply. So we'll go up to 20 ohms. We'll turn the output back on. I'm going to go right up to 60 volts. So that's 178 watts we're getting out of the power supply on just the first channel. So we're currently drawing nearly 3 amps, so pretty much up at the maximum output for the channel, 3 amps at 60 volts. So that's quite impressive. What I'll do now is I'm going to go away and play with this. I'm going to attach the other 2 electronic loads to fully stress all 3 channels. I'll probably leave it running for a few hours and see how hot it gets. One thing I've noticed, I'll turn the scope off. The only fan that's running at the moment is the one that's in the adjuvant. The fans haven't yet cut in for the O1 supply, so either they're not working or it's a very thermally efficient design. Incidentally, it just tells here on the screen of the supply how much power we are producing, and it does closely match what's on the load, so looking quite good. I can now hear the fan on the O1 supply starting to kick in. Not particularly loud yet, so we'll see if it gets any louder. Now of course with both channels going at full power, then I'm sure the fans will get much noisier. Now with these supplies, they're quite nice in terms of the features they have. I haven't looked at the manuals, so I don't know what all the features are, but the ones I did look at were the mode you can operate in, where you can combine the two channels to give you much more power, so you can turn this into a 6 amp 60 volt supply or 120 volts at 3 amps, and then still have channel 3 to drive your logic circuits. So it's quite a nice supply so far. Actually quite impressed with the quality at the moment. It is way better than I was expecting, and it even feels way better than the ones I've had from O1 in the past. So quite pleased with the results so far. We'll see how it goes. We've got all manner of utilities built into this as well, so it's quite a nice supply in terms of the features it has. Again, very efficient thermal design. The fans already shut down in this, so it doesn't look like it's going to have any overheating problems at the moment. It'll be interesting to see how it fares when it's left on full load for a few hours, but it's looking promising so far. You got a programmer feature as well. You can control this through USB or Ethernet or RS-232, and it's also got a record feature, so you can record the values that are being produced, the outputs for each of the channels. And as I say, I'll go through the manual, try all the different modes. If anything interesting pops up, I'll make a follow-up video. But if you do want to see an in-depth review of this, then let me know, and I'll go through all the features one by one. This is just meant to be a very brief look and see if it worked out of the box. Not sure about these connectors. They seem okay, but yeah, we'll see how they go. I prefer the longer connectors, and we do have USB on the front, of course. That's for getting the data out of it. If you want to save the files to USB, it has got a proper mechanical switch, not just a soft switch. And as I say, it's actually quite a nice feeling supply. It is bigger than the Rigel, but it has got twice the output, and the second supply I got is very similar to this. It just has channels 1 and channel 2, and then these two terminals are for sense. So because it's a higher current version of this supply, still 60 volts, but 6 or 12 amps depending on how you combine the two channels. But it allows you to use remote sensing to allow for the drop in the cables. So these two supplies cost me about the same as the Rigel. These will now take the place of the Rigel and my existing older high current supply, and give me a bit more bench space, because these are smaller than the high current supply that I had previously, and hopefully be a nice addition to the lab. And more importantly, I'm hoping these will be a bit more reliable and stay powered up when I'm trying to do experiments. Nothing worse than to come back after 10 or 12 hours expecting an experiment to be finished, just to find out that the supply shut down halfway through it, and you have to start the whole thing again. So as I say, you'll be seeing these supplies much more in upcoming experiments, but if you do want a full review, let me know.